Hey folks, Chuck Black here. We are doing 52 weeks of Python and we are in week 30, and I've done reviews for week 30. We've done 30A, 30B, and now we're in 30C. That's what I call them anyway. And this particular one is looking at the module I called files, which is looking at JSON, YAML, XML, CSV. Obviously, you don't need to have files associated with them, but quite often there are files associated with them. So it's really about data transformation, serialization, etc. And that took too long to write, so I just called it files. Anyway, we're going to look at data as it's stored in Python versus taking it to and from JSON, to and from YAML, to and from XML, and poor old CSV isn't even listed here, but we're going to do that with CSV as well. In addition to talking about those things, I will mention how JSON is used in Quokka. I will mention how YAML is used in Quokka. So that is a general overview of what we're going. Oh yeah, let me tell you too that we use XML in Quokka only indirectly though, because netconf uses XML. So we do have to do some XML-y type stuff. So that's what I'm going to be talking about in this review. So hopefully it will be helpful to solidify what you hopefully know about these data representation languages, getting things into and out of that and those formats. Let's get started. Okay, so let's get started on our review of this section, this module that I've called files. I call it files for lack of a better word. We're really talking about ways to represent data, whether you're serializing it into a file or across an HTTP link or something like that. And the technologies that we're going to be examining, you can see here JSON, YAML, XML, and CSV. Those are code examples that I've created. All of these other ones are just stored versions of the data. Now over here, I've got a slide that shows representations of the data that we're typically dealing with, or in certain cases anyway, we're dealing with. It's the inventory of networking devices that we're dealing with. And here you can see this is my Python representation. And we have, this is the beginning, obviously, of a list. And there's the dictionary and key value pairs, etc. JSON looks pretty similar. The list is called an array. And the thing that we call dictionary in Python is called an object. Again, you have key value pairs. In YAML, it looks different. You have a colon, so you can probably infer that this is a key and that's the value, but you have dashes that means, okay, well, this is a list of things. So that gives you an idea in that regard. And then lastly, XML, these are the only ones that I have right here anyway, to show you XML looks a little bit different, but we will be dealing with that as well as with CSV. So looking at these, we're going to start now talking about JSON because that's the first one. So let's begin to dive into JSON. And basically, here is an example of what we will be doing with JSON in order to get stuff from a JSON format into a Python format. We use load S, and in order to do the opposite, we do dump S. And we looked also in this code, in this lesson, at where we use JSON in Quokka, and we actually use it doing HTTP here, and we so the data that we pass along is JSON, and then when these workers are sending back packet captures or trace route information or port scan, then that is JSON data as well. So let's get started looking at the code. So here we are looking at the code, and at the output over here, let's look at what the code does. First thing that it does is it imports this thing called inventory. That is coming from this inventory file, and this is basically Python data, right? There's going to be a list there, there's a dictionary, whoops, there's a dictionary there, and there's a dictionary here, etc. That is what it is going to be reading in. Now, the first thing that we do is we're going to take this Python data and we're going to translate it into a string. And so that is what JSON dump S. Remember, that's what our Python, that dump goes from Python into a string. And so that's what we're doing first, and then we're going to write it out. So we're writing it out to this file called L00 inventory. The next thing we do is we read in that file, and then JSON inventory is the inventory in JSON format. It's just a string, and we get that from the same file that we just wrote by doing a read. And then I print it out a couple of times. Nothing special there. You can see that it's printed, and it looks similar to what we've seen. There's a pretty version that I did everything. This pretty version, just so you see, I've kind of bundled a bunch of stuff together. The first thing that I do is I take this string, I translate it into Python, and then I take the Python thing and translate it back into JSON. What? Why am I doing that? It's because I'd like to format it in a particular way. You'll actually see this happening some of the time. So this gives you potentially a nice format. And the last thing that we do is we take that thing that we read. Remember, that's this thing. This is the JSON string. We do a load. Remember, load is going to change it into Python. So now we have Python data here in saved inventory. We have Python data from way up here. It's never been touched. That's this inventory thing that we looked at, that we imported. And now we're comparing. So we've written to a file, we've read it in, and then we've done the conversion of what we've read in into Python data. And we're comparing it. And if it works, then it should say that it worked, and it turns out that it does work. So this is how you translate stuff in JSON. If you have stuff that is in a Python format and you want to get it into JSON format, you do dump. If you have something that is in JSON string format and you want to get it into Python, you do a load. And that, my friends, is JSON. And let's review how JSON gets used in Quokka. If you recall back from our slide, we use JSON when communicating with the user to provide data back to the user, and when workers are giving us port scan and other types of information. So if we look really quickly to see how this works, well, the good news is what we get with Flask is all we need to do is return our Python data, and it gets translated into JSON for us. So this is one of the nice things about libraries such as Flask and others. They do stuff that we would normally have to have everybody in the world doing, and so they do it once, and then everybody gets to make use of it. So returning all hosts in this example, all we're doing is we're creating a Python dictionary like this with a key of hosts, and the value, this actually returns a list of hosts, and that gets translated into JSON for us. Now, if I was looking at the Quokka code and I wanted to say, well, where do we do like a JSON.dump_s? Well, if I do Control-Shift-F, you can see I've already typed in a JSON.dump_s, and you can see that it's referenced a number of times. Hey, look, that's exactly where we just were. So it found that in my 52 weeks of Python. There's also some stuff in Napalm where I'm doing it. But if you go down here, then you can see, look, the capture manager and the port scan manager and the traceroute manager all use JSON.dump_s. Remember, that is what we talked about here. These workers are sending JSON data back. So here you can see that it actually is in action. So that is our usage of JSON in Quokka, and we also have the example that we were looking at, this simple code that talks about how to do load_s and to do dump_s via the JSON package. Hopefully that makes sense. So let's now look at YAML. So YAML, as you can see, is quite a bit different than the way that things are represented in Python. With JSON, they were very similar. With YAML, you can see it is a lot more concise, and the formatting is different. You do have similar ideas. So you have a dash here, which indicates that it's a list similar to what you see up here. And you have a colon separating key value pairs. And so the same idea exists in YAML. It's just represented in a different manner. How do you get data into and out of YAML format? Well, the way that you do it is, again, you're doing a load and a dump, similar to what you do with JSON, although for YAML, what we tend to like to do is we use a different function called safe load. The reason that there's a safe load is because of the fact that YAML has the capability to include executables inside it, and if some malicious person put a bad executable, then you could be in danger of executing something that would hack your system. So safe load prohibits that from happening. So we do safe load in order to pull it into Python data format, dump to write it out. Is YAML used in Quokka? The answer is yes, and this is how you see YAML used quite often, and that would be in the form of configuration files. So things like Ansible quite often use YAML to store their data, their playbooks, and so we are storing information about devices, about compliance, about services, and about workers in YAML configuration files. So when we're doing initialization, we are going to be reading in Quokka these YAML files. So let's look at the YAML data itself. Looking at the code for YAML, you're going to see similarities. In fact, they're almost identical to what we do with JSON. In fact, most of these are very similar. The idea is that we take inventory data that's in Python format, we write it out. So here we're doing a writing it out. What does dump do? It takes Python data and converts it into YAML format. So we're going to write out YAML data into this file. And then what we're going to do is we're going to read it in from that file. So now we're reading a YAML file, and YAML inventory is going to have a string version of the YAML formatted data. Now I do the same thing I did before. I print it out a couple of times. Up here you can see me printing it out. This is what it looks like in your in a non-pretty version. I can see that there's an extra space there that makes it look not quite so good. I probably should fix that, but here's my pretty version. It looks a little bit better in terms of its spacing, and you can see what actually is in these files, and the data is actually the same as it was with our JSON example. And now the next thing that we do is the same thing that we did before, which was we are going to take this data which we have read in, we're going to do our safe load, and we are then going to compare the saved inventory with inventory. And it's going to see if what we took from the inventory and wrote out, and then we read it back in, and now here we're doing this conversion using safe load. We're converting it into the saved inventory. We're comparing that with the original inventory. And sure enough, it works. And so that, up to that point right there, is exactly the same as what we do with JSON. The only difference that I'm doing here is I'm calling this alternate formatted data, and it's going to do exactly the same thing, but I want to point out this thing. Look here at credentials. You see how this is listed. It's kind of how you would expect. This is going to be like effectively a dictionary, and the first item in the dictionary is itself a dictionary with the key of password and then the password value, key of username, and then developer. And what if I wanted to store it more compactly? Well, you can do that. You can ask YAML to format things in a different way, and when you actually run the code, and it will do that. And you can see here it's done this particular one. It is actually formatted it in a manner that looks very familiar to us, right? This curly braces says, okay, well, this is going to be a dictionary, and each of these dictionary, the first item is the password item, key and value, and the second item, key and value, are going to be the username. So it's exactly the same as it is in Python. It's exactly the same as it is in JSON and the way that we store it, and it's the same as it is here, but the only difference is the way that it's formatting. This is an alternate format for how you will see YAML data printed periodically, just for conciseness mainly. Okay, so that's this example. Next, we will look at how it is used in the Quokka code. So just as a refresher, how do we use YAML in Quokka? Well, we do it in reading configuration files. So there's a number of configuration files for things like this. There's a little bit of other stuff that goes on as well, but this is what we in general use YAML for. And what does that actually look like? Well, I've done a search across my whole project to find all examples of YAML.safeload. You can see these are the things that we just did in our code, but you can also see, okay, Capture Manager, I'm reading in the capture monitors here, and down here you can see, okay, I'm reading in my devices. Here I'm reading in, I'm calling it standards. This is compliance stuff. If I go down further, you can see that I'm reading in my services. This is import services. And lastly, down here, I'm doing a load of workers, so my remote workers that have been defined. So you can see I do use YAML. I do basically the same stuff that we did in the example there. I am using safeload. Even though I control the input files, it's probably better practice just to always use safeload unless you think you need to execute some code that you've embedded inside the YAML file. So that is the usage. In fact, why don't we just go to one of these devices? So here we're at devices. Basically, we're importing devices when we start up. We are going to be looking at the file that we are opening right here. So we're going to actually open this file. This is my devices file. And then I'm going to do a load, a safe load of, if it is YAML, which it is in our situation, we're going to load it into something called devices, and then I'm going to store it in the database. And furthermore, I'm going to return it to whoever was calling. So that is our usage of YAML for devices, and you saw the other examples for the other stuff that we use it for inside Quokka. Okay, so let's review XML. Now here's a look at the data that we have in Python. As I mentioned, it is different than the other data. I had to change it in order to make it work successfully with the XML tool that I was using. So it does look a little bit different. Here is the Python code, and over here is what it looks like in XML. Of course, with XML you have things in these angle brackets called tags, and then the data is in between it, and you have the beginning of the tag, and if you see a slash here, this is the end of the tag. That's it in general. That's XML in general. Now I am using this library that I found called XML2Dict. So basically what this does is it allows you to easily transform data from an XML format into Python and vice versa. There are many other libraries in Python for parsing XML, and they require a fair amount of knowledge, and you have to do a deeper dive into XML in general. And if that's what you're interested in, that's great. But for the simple purposes of helping us to understand XML and to do it in a simple and easy manner, I've chosen to use this dictionary. And the way that we get things from XML into Python is via parse, and the way that we get it back the other way is descriptively named unparse. So that is what we're going to talk about. And oh, by the way, does Quokka use XML? Not intentionally, but as a side effect of doing some communication with devices. Certain devices that support netconf, of course, will use XML. And so when we talk to devices in netconf, as I do using the NC client package in Python, then I need to parse the XML myself. And so there is a little bit of XML in Quokka. So let's look at the code. And I want you to see at a high level that we're doing exactly the same thing that we did before. The first thing that we do is we get this inventory, and we're going to convert it into an XML string and print it out. The next thing that we're going to do, and I'm going to come back to this, so hang on to your hat for a second, we're going to read it back into this thing called saved inventory. That's actually parsed. And then at the end, I'm going to compare the saved inventory with the original inventory. Remember, XML inventory is what we had in that inventory file. And if it compares correctly, then it works successfully, and I can tell you that it does. Now, a couple of differences to notice. Number one, when I read it in the two other previous examples, I did a read and I saved that textual version. And I'm not 100% sure why I did this, but I actually do the parse right away. So I go ahead and parse it into a Python format. So I use XML to dict, to parse it, and then to save it here. Now what I'm going to do next is I'm going to do a pretty print, and what we're going to see when I do pretty print version order dict, I'm going to look at this and you go, whoa, this looks really more complicated than I was interested in. Order dict prints things out in an interesting manner. It's doing order dict parentheses, and then inside that there's a list, and there's a whole bunch of stuff that I may go into this a little bit in the actual class, so you could dive down into that if you want. But something like this is way better and more easy to understand. This looks like a Python version of that XML, this XML that you see right here. This is what I would expect and hope to see. So how did I end up with this version where I called it dict? Well, what I ended up doing is I took the data that I received via this read, and this is why I did it in this manner. And when I call parse, I passed in this parameter called dict constructor, and by default it will use an ordered dictionary, but I'm saying just use a regular dictionary. And the result when I print it out is it looks nice and normal. The last thing that I do is this thing that I've tended to do, which is to take the Python thing, unparse it into XML and print out the string. This is my string version of that XML. So that is kind of what we're looking at in terms of XML-ishness. And then I do this comparison like we mentioned, and it turns out to work okay. So just pretty quickly, XML to dict is the library that I'm using, and I use unparse to go from Python into XML string format, and then I use parse to go from the string format, which is XML formatted, into a Python data structure. There, that's how we deal with XML in a simple manner. Hope that helps. Okay, so let's look at what we do with XML in Quokka. And guess what? If you look here, you can see, oh wow, that's all from 52 Weeks of Python, and we haven't done this yet, or I haven't recorded it yet. Maybe by the time that you watch this, I will have, but this is also part of the 52 Weeks of Python. So I don't actually use XML to dict in the Quokka code. The reason for that is not because I don't think that it would be useful to do that. I actually do, but the reason is that I didn't know about XML to dict until I actually recorded the class, this class here, my XML example class that I did a few weeks ago, and I haven't gone back to change Quokka for the one device type that I do use, NC client, which is a netconf client, and get XML data back, and I may change that and modify it at some point. But for right now, I don't actually have code that uses it. My code uses the other libraries, not in a terribly intelligent way. When we do get into netconf, you can look at the netconf example, and you'll be able to see a little bit of how I use it. What I'm actually using there is this LXML, which allows me to kind of traverse the tree of XML data. But nothing using XML to dict in Quokka right now, so nothing to show you, nothing else for you to look at. So sorry about that, maybe in the future, but for right now, for this review, you'll have to be satisfied with this L03 XML example. Hopefully it's straightforward and easy for you to understand. Okay, so the last thing we're going to go over in this review is CSV. Now, CSV data basically stands for comma separated values, and basically the idea is that you have these values, say from a spreadsheet or something, and the values from that table are just separated by commas, and they're listed in this format. So it is very concise, obviously. Alternately, or one of the options, optionally, you can have as the first line is actually the the heading of the different columns so that you know what they're all about. And we'll look at that in just a little bit. Now, if we were to translate this directly into a list of lists, which if you see a bunch of comma separated values, that's what you would immediately assume this is, then it would look something like you see down here on the left. So this is all of my items from over here in Python data format. But if you were to go a little bit further and think about this, you would say, well, the column names, those could be the keys, and then it could be a list of dictionaries. And in fact, this is a list of dictionaries version of that data right there. So in the code, I'm actually going to show using both of these. So that's what we'll look at next. So let's look at the code that's typically used to do CSV stuff. And I think what you're going to find, I know what you're going to find, is that it's done a little bit differently than the others. In the other situations, we were dealing with either strings that were in JSON or YAML or whatever format, and then we wrote them out using normal writing mechanisms. With CSV, we actually create a CSV writer, and we write rows or we write whatever using that CSV writer. But we're doing effectively the same thing. So what are we doing? We have this thing called CSV inventory in our inventory file. We're using that, and we first create a writer and associate it with this file. And then we say, I want you to write your rows, and it's going to take this Python data and it's going to write it out in CSV format. The next thing that we do, which is similar to what we've done before, remember this is overall at a high level the same thing we were doing before, where we took the data and we wrote it out. Now we're going to read it in, and we, in a like manner, we're going to create a reader and associate it with this file. And then what we're going to do is we're going to iterate through the lines of this file using CSV reader, and every line represents a device. In our example, you could call it whatever you want, but we're roughly building this list by appending what we've read in using this CSV reader. So again, look at the lesson itself for more detail, but that's basically what we do. I print it out. We print out a pretty version, and you can see that printing it out, a list of lists, that just goes on forever to the right. A pretty version gives us a little bit easier to see. And then, of course, we do our same comparison of what we read in, wrote out, read back in, converted to with the original thing to make sure that it's okay. And sure enough, it's okay. After that, I went through a few different operations where I changed our list of list into list of dictionary, or I read things in as dictionary objects. And so this is what we're looking at here, the first. And why did I do this? Just because it was fun to do and thought it might be a useful exercise for you guys to be familiar with and to try to parse what I did. So I'm going through all of my devices, and for every device I'm going to end up creating this dictionary that has the key is going to be the header, and then the value that it's storing is going to be all the appropriate piece of data that's appropriate for that header. So this creates a list of dictionaries. If you look down here, isn't this a lot easier to deal with something like this? If it's a list of lists, then I have to say item 0 is this one, item 1 is that one, and while we humans can just look at it and say that's okay, if I'm writing code, that would be really hard to do. But if I specify the key of hostname, it's this value, then you can see dictionaries are way better. Now, the last thing that I do, and I'm not going to spend a ton of time because I'm kind of doing a similar thing, is I'm going to be reading a bunch of stuff in from a spreadsheet that I created using Google Sheets. So it's the same as XML or whatever, but I just created this thing and I had it write out the headers as well. I did my trick of turning it into a dictionary. So I've done this. This is the same as what we did before. I print it out. So this is my list of all of these different things. And then I used our friend, Mr. Ms. Tabulate. I'm not sure which gender to give it, but this tabulate function that we've used off and on, I'm saying print out my devices using tabulate, and it did this for us. And this is what it ended up with. This is what I put in the spreadsheet. This is different than our inventory. It's from a spreadsheet. And then I went ahead and wrote it out, and I'm writing it out using DictWriter. So I have a list of dictionaries. This is what you see up here. This is a list of dictionaries, and I'm going to write it out using DictWriter. So basically it's going to be able to create a CSV file, and it is going to use it as assume that it's a list of dictionaries, and it will write it out appropriately. And that's what this code does. And the last thing I do is I compare the data from the spreadsheet with what I just wrote out. And guess what? It's going to fail, but it's expected to fail. And I just reviewed this, so I will review for you. Why did it fail? Let me show you. Here's the one that I read in, and here's the one that, let's see, I can't even remember which one that it is. This is the one, this is the other one. So if I were to put these side by side, this is devices for this is what I read in, this is what I wrote out. And if you were to look at these, they look exactly the same. And guess what? The writer adds a line at the very end. I would have had to trim this file by a line. So in essence, we look at it and we say it's the same, but in actuality, it's not exactly the same. So the computer says it's no good, but we know that it actually is good. Let me get this back. Where are we? CSV example. All right, you can go away. And so this is our code to do CSV. Hopefully that makes sense if you have to deal with CSV files, which can be useful. I know a lot of people showed an interest in this when I came up with the lesson, and hopefully this will help you to remind you. If you've gone through the lesson, it will make it stick in your brain, and if not, then this will give you a taste of how we do things with CSV in Python. Okay, I'm going to quickly breeze through what we talked about. So these are different ways of representing data. This is what it looks like in Python. This is JSON. This is YAML. This is XML. And we also did CSV. So that's what we talked about at the beginning. We talked about going to and from JSON using load S and dump S. I think the S stands for string. And that's how you get things from JSON into Python, and vice versa. We did look at how JSON data is actually used in Quokka, and it's used in a couple of places, typically associated with HTTP requests. Then we talked about YAML. YAML is something that's also used in Quokka, and it's used quite often in the networking space. It's more concise. Its format is different, and lines matter and things like that. We do a safe load because there can be executables over here. So we do a safe load to pull it into Python, and to put it out to Python into YAML, we do a dump. And yes, indeed, we do use YAML files in Quokka, mainly their initialization files to tell us about devices, services, workers, etc. We then went ahead and talked about XML. XML is quite verbose, and it has these things called tags. And I used XML to dict as one way, a simple way to go from XML into Python and vice versa. And the methods we call are parse and unparse in order to do that. And I mentioned that yes, XML is used indirectly because netconf, when you talk to devices, is going to send data back in XML format and make requests in XML format. Then we talked a little bit about CSV. CSV can be stored as list of lists or lists of dictionaries. And this is what CSV files look like. In order to know how to get them back and forth, I don't know if I went over this, but to go just list of lists, you do readme, reader and writer. And to do to and from list of dictionaries, you do dictreader and dictwriter, because that is a popular thing to do. That's what we talked about. Hopefully you understand all of these data transformation mechanisms for the different types of formats that data can be stored in, and you have a better understanding of how to deal with JSON, YAML, XML, and CSV. Thanks for listening to the review.